Hi everybody, this is Miss Welch, and today we're doing lesson 3.2.1, How Can I Check My Answers? Solving equations and checking solutions. In section 2.2, you learned to solve equations on an equation mat. In this section, you will practice your equation solving skills while adding a new element. You will check your answer to make sure that it is correct. While solving equations in this lesson, keep these focus questions in mind. What is your goal? How can you start? How can you simplify? Can you get x alone? Please make sure that you have your paper labeled. It's lesson 3.2.1, and we are on question number 3-71. What is a solution? In this lesson, you have found a solution to an algebraic equation. But what exactly is a solution? Answer each of these questions with your study team, but do not use algebra tiles. Be prepared to justify your answers. Letter A. Preston solved the equation 3x minus 2 equals 8 and got the solution x equals 100. Is he correct? How do you know? Letter B. Edwin solved the equation 2x plus 3 minus x equals 3x minus 5 and got the solution x equals 4. Is he correct? How do you know? And letter C. With your partner, discuss what you think a solution to an equation is. Write down a description of what you and your partner agree on. Please pause the video and try and answer these three questions. For letter A, we're going to try to see if x is equal to 100. And what we do for that is we take the x out and we substitute 100 in its place. So 3 times x becomes 3 times 100. We still keep the minus 2. We still keep the equals 8. We're just trying to see if this makes a true statement. So 3 times 100 is 300. 300 minus 2 is equal to 298. That is not equal to 8. So this is not a solution. We know that it's not a solution because 100 does not work when you put it in the equation for x. For part B, Edwin believes that x is 4. So we're going to take all of the x's out and we're going to put 4 in its place and see if we get the same value on each side. Okay, so I've got 8 plus 3 minus 4. Does that equal 12 minus 5? 8 plus 3 is 11. 11 minus 4 is 7. 12 minus 5 is 7. I do get the same value on each side. Both sides are worth 7 when I put 4 in place of x. So Edwin is correct. The answer for part B is 4. Part C, one description for a solution might be something like solution is a value that makes the equation true. Question 3-72. Work with your partner to solve these equations, being careful to record your work. After solving each equation, be sure to check your solution if possible. Now please pause the video and you can try all 4 of these and then watch the video again, or you can try them one at a time and then come back and watch the video after each one. Letter A, 3x plus 4 equals x plus 8. Now I am not using the equation mats, but I am going to use a lot of information from there. For instance, I'm going to start with drawing this line down the center because on my left mat I've got a 3x plus 4 and on my right mat I've got an x plus 8. Now, one of my possible first moves might be to remove identical tiles from each side. I'm going to remove an x from each side. After I remove an x, I've got 3 x's, take away one of the x's. I've got 2 x's left. I still have my 4 unit tiles. On the right side, I had an x, but I removed an x, so now I just have my 8 tiles left, my 8 unit tiles. Next, I want to get the x's all by themselves, so I'm going to get rid of that plus 4. I'm going to remove identical tiles again. I'm going to take 4 units off of each side. When I remove 4 unit tiles from each side, on the left-hand side, I'm left with 2 x's. And on the right-hand side, I had 8 unit tiles. I removed 4. I've got 4 left. Now, the last step that I wanted to do is I had 2 x tiles equals 4 unit tiles. I'm going to put those into individual piles, and I can divide it up into 2 piles. So I'm going to divide both sides by 2, and I end up with each x tile is equal to 2. Now, when I check my answer, I usually just use a check mark there. Everywhere in my original equation, I am going to put a 2 in place of x and see if I get the same value on both sides. So 3 times 2 plus 4, is that the same as 2 plus 8? 6 plus 4 is 10. 2 plus 8 is 10. I get the same value on both sides, so I know that my equation x equals 2, my answer, x equals 2 is correct. Here is the same problem solved 3 different ways. Instead of subtracting x first, in the red one here, I subtracted 4 first. In the blue one, I subtracted 8 first, and in the pink one, I subtracted 3x first. And I just wanted to show these to you just to let you know that the way that your teacher does it is not always the only way to do it. For this, no matter which way we did it, we always got x was equal to 2. My personal preference is to get the x's on the same side as soon as possible. So of these 3 choices, I like this one the best, just because after I do that step, I only have x's on one side. I don't have x's on both sides anymore like I do on those other 2. Part B, 4 minus 2y equals y plus 10. So I am going to start by removing identical tiles. I'm going to remove a y tile from each side. On the left-hand side, I had 4 unit tiles. I still do. If I have negative 2 y tiles and I want to take away a y tile, that ends up to be a negative 3 y tiles. A positive y tile and a negative y tile, it's a 0 pair. I have my 10 left. So now I've got my y's all together on the left-hand side. Next thing I'm going to do is remove identical tiles for the units. I'm going to remove 4 unit tiles from each side. If I have 4 unit tiles and I take away 4 unit tiles, I've got nothing left there. I still have my negative 3y tiles though. 10 unit tiles minus 4 unit tiles would give me 6 tiles. Now we've got 3 negative y tiles. I can divide those into 3 even piles where there's 1 negative y in each side. Each pile has 1 negative y tile. And then 6 divided by 3 is 2. Now if negative y is equal to positive 2, and I don't want to know what negative y is, but positive y is equal to negative 2. It's just taking the opposite of each side. I am going to check my answer again. I think y is equal to negative 2. So 4 minus 2 times negative 2. Is that the same as negative 2 plus 10? This is 4 plus 4, which is 8. Negative 2 plus 10 is 8. So my solution, y equals negative 2, is correct. Letter C, if I had my tiles, the first thing I would do would be to flip on the right-hand side, because in my negative region, my opposite region, I've got x plus 8. The opposite of x would be negative x. The opposite of 8 would be a negative 8. Also, I probably combine like terms on the left side at the same time. I've got positive 5x's and negative 2x's. If I take out my 0 pairs, that gives me a 3x plus 4, which is equal to negative x minus 8. Next thing that I personally like to do to get my x's on the same side, I think what I'm going to do is add an identical tile to both sides. When I do that, I've got 3 x's on the left with another x, so now 4x. I still have my plus 4. Here I now have a 0 pair because I have my negative x and my positive x. That makes a 0 pair, and I've got just negative 8 left. Next, I'm going to remove identical tiles. Now that I've got all of my x's on the left, I want to get rid of that plus 4, so I'm going to remove 4 positives from each side. When I do that, my positive 4 tiles and negative 4 tiles will cancel out. That's a 0 pair. I've got 4 x's still. Now I've got negative 8, and I tried to take away 4 positives. Negative 8 minus 4 would be a negative 12. I can take my 4 x's and I can divide them evenly into 4 piles. So I'm going to do the same with the other side, divide them into 4 piles. And I get that each x pile is equal to negative 3. So I believe that x is equal to negative 3. I'm going to check that back into my original equation. So I've got 5 times negative 3 plus 4 minus 2 times negative 3. Does that equal the opposite of negative 3 plus 8? So I've got negative 15 plus 4 plus 6, and the opposite of 5. Negative 15 plus 10 is negative 5. Opposite of 5 is negative 5. I have the same value on both sides, so my solution, x equals negative 3, is correct. Letter D, negative 2 plus 3k minus 2 is equal to negative 2k plus 8 minus k. First thing that I'm going to do is combine like terms on each side of my mat. So each side, my left side, I've got 2 negative unit tiles and 2 negative unit tiles. When I put them together, that's 4 negative unit tiles. I still have that negative 3k. There's nothing to combine with that. On the right-hand side, I've got 2 negative k tiles and another negative k tile, so that's 3 negative k tiles, and I still have my positive 8. Next, I'm going to remove identical tiles from each side. I've got a negative 3k and a negative 3k on both sides. I'm going to remove those. That looks like removing negative 3k and removing negative 3k. What I have left, because this would be, I took off my 3k's, so I've got negative 4 on the left-hand side. I took off my negative 3k's on the right. I got a positive 8. All of my variables canceled out, and I've got negative 4 is equal to positive 8. That is not true. If I get something that is not true, then my answer ends up being no solution. There is no value that I couldn't put in place of k that would give me the same value on both sides. So no solution is my answer. Today's math notes are just a checklist of things to make sure that you have a complete graph. One of the things is make sure your x and y axes are labeled. And make sure that you're clearly showing what your scale is. What are you counting by for the x's? What are you counting by for the y's? And make sure that it's evenly spaced. Make sure you have your equation on your graph so we can see what that is. Extend your graph as far as possible on the graph and make lines on there, make arrows on there if that works. And then coordinates of special points stated in XY format. You might state like this is over 0 up 6. And this one here is over 2 up 0, something like that. It says that your tables can be formatted horizontally like the one above or vertically as shown below. And then there's an example of a completed graph. Your assignment today is lesson 3-2 if the problems are 374 to 378. If you are in the math book, it starts on page 25.